So here's first bit of sample rate reduction from 600 kilohertz to 60 kilohertz, which obviously won't do much. Gets rid of some of the noise. Part of that is a function of my function generator. It's pretty old and crappy, so there's a lot of ringing on the clock signal, which is fine. I have a ton of high frequency, high quality clock signal generators. Alright, going down another decade. Starting to hear some of that ringing, characteristic of sample rate reduction. We are at about 6 kilohertz for sample rate. Bringing it down a little bit more. Another decade. And so, yeah, add some modulation. And now I'll bring in the synth. Modulation on the sample rate. Bring it back down. Just the synth. Back in. All the sounds are just coming from the mono tribe. I've added input and output modifications, snare, decay, synth hit changes. This is a demo of the circuit in octave mode. You can see that the signal going in is 8.4 kilohertz and that the signal coming out is 4.2 kilohertz. This works across the audio spectrum. I have a square wave going in as my test source and a square wave coming out. You can see that there's some staggering here. I'm only using 4 of the 8 bits in octave mode just because there wasn't room on the breadboard for 2 more ICs. A secondary modulation option through a secondary clock on the DAC, because the DAC has a DAC A, DAC B, so we can add a vibrato or a panning depending on the speed. So here's that. And you hear it adds harmonics, adds kind of an aliasing sound. Obviously you filter some of that out. And if you get very low frequency, you get gating. Combine the two. This will be an example of sample rate reduction. I'll do an example with a basic sine wave, and then I'll do something a little bit more musical, because sine waves can be kind of annoying to listen to for extended periods of time. So real quick. Sample rate right now is at 60 kilohertz. A second ago it was at 600 kilohertz down to 6 kilohertz. This input waveform is at 900, so we're 6 times Nyquist. And so yeah, you see, works as expected. And if we put some modulation on that, okay, this time it's the same rhythm as before. Only this time I'm going to be messing around a little bit with the individual bits of the ADC. So right here.